So the lab is about linear regression. Okay, so first let me just rename the file. Okay, so we're gonna use scikit-learn. Okay, scikit-learn is a library. It's a robust library for machine learning in Python. So the library provides various tools for machine learning, including classification, regression, clustering, and dimensionality reduction. So the library is built upon NumPy array. Okay, so here first we import uh, the commonly used uh, library such as the NumPy array and pandas. Okay, scikit-learn comes with a few standard data set. So if you want to know the what are the data set, you can go to the documentation. But in this lab, we're gonna use the Boston data set. Okay, so we import the data set into Jupyter. Right. So then now we can use the data set. Okay, so Boston here is a dictionary. Okay, contains the data, the target, the feature names, and description of the data set. All right, so uh, we retrieve the data. Okay, put it in the data frame. So, okay, so here we are retrieving the data, and also we retrieve the feature names, columns. Right. Okay, and let us add the column. Okay, for the target price. Okay, so and we display. Okay, so we display the data frame. So I just display the first a few first rows of the data set. Okay, the first 5 rows of the data set. Okay, so we have I think here we have the okay, so we have 13 features and one target. All right. Okay, so we can use so since it is a data frame, so we can use the function correlation function just um, to know which features relevant to the target. Okay, so correlation matrix here is basically just a data frame. Okay, so it calculates the correlation between the columns. All right. Okay, so now we display the last column, which is our target, so that we can see the correlation values between the features and the target. All right, so as you can see here, okay, so if the correlation value is close to -1 or +1, then we know that uh, the features have a strong relationship with the target. It could be inverse or direct. All right, it could be a positive or negative uh, relationship. Okay, so let us build the model. Okay, the linear regression model. All right, so before that, we have to split our data set into training set and test set. Okay, so we can use function, okay, in scikit-learn called train test split. Okay, so then we just use the function to split our data set. Okay, so let's say we use the okay, probably we just call them as that the PT ratio, and so let's say okay, okay, so we just here we just this is the data, and this is the target. This is negative one is basically the last column, okay, which is our target. All right. Okay, so then if you want to, you can set the random state to a value so that you can reproduce the same split. Okay, so we have our training set and test set. Okay, so as you can see, our training set consists of 379 rows, and our test set is has 127 rows. Okay, so now let us import the class, the linear regression class from scikit-learn, sklearn, linear model, linear regression. Okay, okay, so then we okay, feed here. So feed function is the train function. Okay, the training function. Okay, so we train our model. Okay, so we pass our, remember, data and target. Okay, right. So we have our model. Okay, so we have our model. Okay, we have trained the model. Okay, now let us use the test set. Okay, to evaluate the model. Right, predict X test. So we pass only our data. Okay, so that we can, um, we want to evaluate. Okay, so here is basically our prediction. Right. So we have the prediction. Okay, now we use the performance metrics. Okay, such as mean squared error. Okay, and then the R squared. Okay, so we pass the Y test and the prediction. Okay, so that's basically uh, our mean squared error. Okay, the error of the model and the R squared. Okay, of the model. Okay, so now let us build a linear regression model using the gradient descent. Okay, so we just call this call the class. Okay, we just import the class sgd compressor. Okay, right. So then we just okay. So we have to specify a few parameters. Okay, so the first one is the loss function. Okay, so we um, okay, so I'm using this Huber loss. Okay, so this is a modified squared error. Okay, squared error loss function. All right, so if you go to this documentation, so the default is a squared error. Okay, but we can also use this Huber loss and other loss function. Okay, so so Huber loss is a modified, okay, is a more robust loss function, okay, so that the training is not sensitive to outliers. Okay, so we can set the learning rate. Okay, so ET is 0. Okay, so let's say 0.35, and the maximum iteration is, let's say, 1000. Okay, so I want to disable this early stopping. Okay, um, we will discuss early stopping in the later topics. Okay, so the tolerance also I set it to none. Okay, the I want to see this, the training progress. Okay, and then also this random state 1. Okay, so we have specified the parameters. Then I want to then I pass the X train and Y train, okay, to train the model. All right, so we have the model. All right, so we have trained the model. All right, so then we can now evaluate the model on the test set. So just copy this one. All right, so it seems to be not better than the least squared. All right, so we have to fine tune the parameters so that we can get uh, a better model. Okay, so we might need to increase the iteration, let's say to, 3000. Okay, so it's much better now. Okay, so we have to fine tune the parameters. Okay, uh, so that we can have the an optimal model.